Good morning, and thanks very much for the invitation. And I'm very aware of the time, and I will try and whip through this very quickly. So when it comes to livestock, they are a very important contributor to the global climate change. And I think I'd just like to set the scene a little bit, that we have a global target of 1.5 degrees. We want to stay within that. And where does agriculture in general need to get to? And where does the world need to get to? And just this is quite a complex graph, but if I hope you can see my pointer. The red line is where current pledges will get us. And if the UN issued a report yesterday that said we're currently around 8.8% above 2010. And so we are very much on track with that red line. But where we need to get to, if we want to stay within 1.5 degrees without overshoot, and that's only a 50% chance of staying within that, we need to get to the blue line. And there is a massive challenge between those 2 points. And I think what I'd like to set in context today is how can agriculture contribute to that? And how can livestock contribute to that? Because at the moment, it doesn't look as if we will be able to stay within 1.5 degrees. And the report yesterday said we're on track for somewhere between 2.1 and 2.8 degrees, unless we find ways of mitigating emissions very quickly. So I'll stick more to livestock. So, what amount of warming does livestock cause? Not an easy calculation. We normally talk about emissions. But myself, my colleague Andy Reisinger, had a go using a climate model and historical emission trends to look at how much warming livestock actually contribute to global warming. And our best estimate is that livestock, once you consider nitrous oxide, methane emissions, and some contribution from carbon dioxide from pasture conversions, livestock contributes very close to 1/4 of the current climate change. When we did this study, it was just over 1 degree, and 23% came from livestock. So not far off 1/4, and that contribution is continuing. So livestock mitigation is important for us achieving the 1.5 degree goal. Now, this is from AR6, something on emissions, and where are emissions going from the livestock sector. And unfortunately, IPCC reports don't break down livestock particularly into a separate segment, but we can see certain categories of emissions solely from livestock. And if we look at enteric fermentation, this is AFLU, so it's agriculture, forestry, and other land uses. But enteric fermentation is the biggest emission from livestock, and it's been growing. And if we also look at emissions from managed soils, we look at emissions from fertilizer, which a lot of used on livestock, emissions are growing. But globally, that is unbalanced. We see places like Europe where emissions actually have gone down. And we look at the categories of enteric fermentation and managed soils. But if we look at other areas in the developing world where livestock is an important issue, both culturally and for food supply, where we have very large increases in populations, we're seeing livestock emissions rise, and particularly Africa, Latin America, and South Asia. So we have quite a patchy picture globally. But the message from this is that despite many years of saying we can mitigate emissions from livestock emissions are actually rising. Why are they rising? At the end of the day, we have got 2 billion more mouths to feed. So we've got a big increase in consumption of milk and meat products. So although there's in the developed world, we hear that we perhaps should eat less milk and meat, globally, there has been an increase in milk and meat consumption, and we're expecting that to continue. And there are various estimates of what we need, what will happen with milk and meat consumption, but all of them say major rises in the demand for milk and meat products. And that's it resulted. We've got increased fertilizer use, we've got increased livestock populations, and we have increased production per animal. All of that leading to greater emissions. And I was asked to talk a little bit about measurement challenges. It's very easy to say, yes, this is what the emissions from livestock are, but how do we actually even calculate those? And I will stick mainly here to enteric methane as perhaps the most difficult one and the biggest contributor to agricultural emissions. We have something like 3 billion animals across the globe, all of emitting methane quite continuously. So how do you get from 3 billion point sources up to the world emits 6 gigatons? And so we have a measurement challenge, both at the individual level and how we can scale that, scaling through time, scaling from individual to group, to farm, to national, to global. And we have to accept there's a large error in any estimate of emissions when we look at any scale, both from the individual to the global. We have an issue of variability when we're trying to look at measurements for individual animals and at larger scales. There's the cost, there's what kind of equipment we need. Often they're quite labor intensive. They can be very complex. And if we're thinking of enteric methane, the biggest driver of enteric methane is intake. And how do we estimate what animals across the globe are eating and what is the quality of that diet? And often we're measuring in quite artificial ways, and I'll expand on that slightly more. And just to give us some nice pictures, and these pictures show developments over close to 50 years. If we look at the bottom right-hand corner, these are respiration chambers where we enclose animals in various types of box, and we can measure very accurately the methane emissions coming from the animal's mouth. And they've been used for 60 to 70 years and are still in use now and are the most accurate way we can measure from individual animals. If we look to the top right-hand corner, we can have a very cheap way of measuring enteric emissions from the mouth of an animal by enclosing the animal's mouth in some kind of container. Not used widely, but quite cheap, but obviously you can only do that over an animal's mouth for a short period of time. Then in the 1990s, we had a real change. We had the sulfur hexafluoride technique, and that's the animals with these containers either on their backs or around their heads. And this allowed grazing animals to be measured, and then they could be non-grazing animals, and it was done by the use of a marker gas that's emitted at a known rate from the animal's mouth. And that was used a lot between 1995 and the early 2010s. Then if we go right to the bottom left-hand side, there was another revolution in measurements of individual animals called the green feed technology, first unveiled in 2011, and where animals voluntarily go into a container, put their head into a container for small amounts of time, and methane is measured for a few minutes, and then by continuous measurements over many days, you can estimate what the animal emissions are per day. These are turnkey systems and are now the most common way of measuring methane. Now, all of these have their pros and cons. There's no one system that's best for all circumstances, but they do illustrate the complexity and challenges of measuring emissions at the individual animal. But then when we think about emissions from countries or regions, how do you scale? How do you get from emissions of an individual animal to emissions of a region, emissions of a country? And in many cases, we don't even know the population. Now, in developed world, we do have good population estimates. In the developing world, we'd be lucky to know how many animals there are. Then we don't know what they eat. We don't know the quality of their diets, and we're making educated guesses. I think in some ways to scale from the individual animal up to the country. But we've over time have developed better ways of getting emissions from countries. And we're using, and that scaling issue, we're now at the stage, can we scale from the individual to groups of animals using very complex sensors and highly accurate sensors and equipment, right through currently to, can we measure from satellites? Can we actually use aircraft? Can we use satellites to measure at broad scales what emissions from animals are? Now, when we come to country, and I'm sure you're very familiar with this, many countries simply use animal numbers times a factor. But we can get it much more complex than that, but we need massive amounts of data. And this is just that New Zealand has one of the most advanced national inventories, but it requires enormous amounts of data. And we've had a 20-year project to try and better estimate emissions. And even now, the uncertainty estimates of our emissions, for methane, they're about 20%, and for nitrous oxide, they're about 50%. And that's regarded as good. If we then look at global assessments, cut a long story short, the IPCC uncertainty estimates are that for methane and nitrous oxide from livestock agriculture, we're talking about 30 to 60% uncertainty in the numbers. So, it's fine having targets for what we reduce, but we have to acknowledge that there's a lot of uncertainty around the emissions that we estimate. So I'll move on to mitigation and think what's the size of the challenge? I mentioned already that livestock emissions are rising. And despite many entreaties to eat less meat or less livestock products, the world is eating more. And that has meant more emissions. If we look at the kind of trajectories that we're being asked to follow, and this is very stylized, to try and, at the bottom range of ambition, to keep within the 1.5 degree goal, we need to reduce livestock emissions by between 20 to 25% at a minimum by 2030. Given that we haven't reduced them in 3 decades, perhaps I'm pessimistic, but I really don't think we will actually meet those goals in the next 7 to 8 years. We have not done anything in the last 3 decades. If I think we look at academics, we can see that there is some cause for optimism. And again, we don't get breakdowns from the IPCC in terms of livestock per se, but we do get methane and N2O, the vast majority of which comes from livestock. And these are done at certain costs of implementation. And if we combine carbon sequestration and the reduction in methane, we can get close to very large reductions. But there's huge uncertainty in these. And interesting enough, they're all at a certain carbon price. Throw out the challenge, how many countries have imposed a price on emissions in agriculture? And how much can we exploit the voluntary market to get a reward for mitigation actions? Compared to the size of the emissions, it's very, very small. And so there is a great degree of artificiality in these numbers. So how do we mitigate? What's the state of the knowledge? And I think I've tried to synthesize this down into 3 areas. And all areas are where we need to focus if we're going to meet the challenge of mitigating emissions. And in common with the previous speaker, we have to mitigate emissions at the same time as adapting to climate change. They're not it's not an either or situation. We have to do both. We have to keep producing more food, less emissions, while adapting to climate change, which is challenging. It's a wicked problem. So if we actually look at one end of the spectrum, and this has been going on for decades and centuries, we need to increase the efficiency of the way we produce food and the way we produce livestock products. And they are known practices and are being implemented, but are they being implemented fast enough? And that's improved genetics, improved feeding, improved animal health, improved reproductive performance, improved management, fertilizer management, reducing losses during storage, etc. These are known, but what we have to do is get them implemented quicker. We currently are doing that. If we look at emissions per unit product, they are falling throughout the world, but they're not falling fast enough to contribute to the targets of reducing absolute emissions. So we have a challenge in implementing known practices. In the scientific area, most of the focus is on new technologies. And we'll see every day there's a new promising technology to reduce methane in particular. And we know a lot, and a lot of things are coming on the market, but how many of them are actually implementable currently at a cost that is acceptable to the community that has to implement them? We have a lot of things that are talked about, but how many of them are actually available and how many of them are being implemented? So that's something for the future. And I think in the next 5 to 7 years, when we're trying to get emissions down in 2030 to a target that will keep us below 1.5, I think there's a very strong challenge of how many of these new technologies will be available and taken up by 2030. And the last one, which receives a lot of publicity in the wealthy world, is, do we constrain production? And we're already seeing examples around the world. Nitrogen fertilizer limits. Do we have to reduce animal numbers? Some countries have really put that forward as policies. Stocking rate restrictions. And do we need to reduce the demand in some areas for livestock products? And I don't think, as I said, it's an either or. We need to be looking at all of these things to get emissions down. Just to give an example of the efficiency in action, if we look at emissions per unit product, and this is just a milk example, as the milk production per cow increases, the milk production per unit product goes down. It's again very stylized. I thank Pierre Gerber for this graph. And we can do a similar graph for most livestock products. And so there is a huge scope from productivity to, in a sense, continue to produce more food, but without producing greenhouse gases. The challenge is implementation. So if I look generically around some of the new technologies that are coming along, and again, I don't have the time to go into these in great detail, but we've got we've got possibilities in animal and feed management, genetic selection. We can select for animals that have reduced methane emissions. Can we have specific feeds that reduce methane or nitrous oxide emissions? And that comes to better diet formulations. Certain elements of the diet, for example, protein management. In some livestock systems, we need to decrease protein. In others, we need to increase protein. We know that lipids can reduce methane emissions. We know that there are certain plants, taniferous plants, that can reduce emissions. And we now know that we've got things that we can manipulate in the rumen, like additives, new products that are coming along, with lots of publicity around seaweed, and they can make huge differences, but they will only make differences if they're implemented and implemented widely. So we do have tools coming along that we can hopefully be implementing over the next few years to make a dent in livestock emissions that allows them to go below what they currently are. But my question as a challenge is, are our mitigation estimates realistic? I think at times they're far too theoretical because, as I said earlier, we have 3 billion animals roughly on the planet who produce, say, for example, methane. We have 500 to 600 million livestock farmers. It's a challenge to get them all to mitigate. How do we do that? And I go back to the IPCC, which is, it's the Bible for policymakers in many ways. And it shows and states that there's very good options to mitigate emissions from the agricultural sector. But then when you go to the small print, it starts talking about, although economic potentials can give you some, what the term more realistic mitigation options, they don't account for the feasibility barriers in enabling conditions that vary markedly by region and country. And I think we are far too optimistic. And I think if you read the small print, the IPCC admit that. And then we can go to a specific piece of work that came out last year, a very thorough and elegant piece of work by the global community that tried to look much more about the strategies and the uptake of strategies. And it said that full adoption of the most effective strategies could help meet the 1.5-degree target by 2030, but not by 2050. But I think the key is the words full adoption. Do we ever get full adoption of any mitigation or practice? So again, I think what we have to take from that is that we won't meet the target because we don't actually have enough implementation of the practices to meet that target. And so my message today is we need a lot more consideration of the barriers to uptake before we can, I think, be confident that we will be meeting the targets that are being set for the sector. And I think we need to work a lot through farmer knowledge, a lot more around how we can enable implementation of practices on the farm, because that's where the rubber hits the road. It's the people who have to change what they're doing, change to new practices, and how do we encourage that? And I think in common with the last speaker, in the past, we thought it would be governments who would be driving this. But at the moment, it's really non-governments. We're seeing globally, industry is now a major driver. And farmers in certain jurisdictions blame the government for imposing practices or change on them. But in actual fact, it's the market that's going to be the major driver. But to meet the barriers and for livestock to meet the stern targets it's got to meet, if it's going to contribute to us, the world staying in 1.5 degrees, we have to pay much more attention to the barriers to uptake rather than focusing so much on technology solutions. It's about implementation of solutions, and that's where we need to focus a lot more and need to harness and focus a lot more investment. Thank you.